Um, I'm Sam, and I will be talking about JSON Web Tokens today. Who of you has ever heard of JSON Web Tokens before? Who knows how they work? I see some hands going down. I hope I can teach you a thing or two about JSON Web Tokens, and if not, well, we'll see what happens. So, let me quickly introduce myself. My name is Sam Bellen. I'm from Belgium. I'm a bit jet lagged, so sorry about that. If I seem a bit tired, it's just because of the jet lag. I am happy to be here. So, I'm a developer evangelist at Auth0. And if you've never heard of Auth0 before, we're an identity as a service provider, which basically means that we try to make it as easy as possible for any developer to implement a secure authentication flow so you can focus on building your actual product. I'm also a Google developer expert, which means nothing, so just that Google decided that I know a thing or two about something. I organize a few meetups, one in Belgium, one in London. If you ever have the chance to come to Belgium or London, join our meetup. And if you're on the internet and want to follow me, Sambigo is my username on most of the websites. Our company became a unicorn last week, which is something very exciting, which means that our valuation is now more than $1 billion. We're very happy with this, of course, because everybody wants to have a company that's very valuable. So I have cat stickers. If you want a cat sticker, send me a tweet with a cat photo, a dog photo, a bunny photo, any photo you want, and I'll give you some cat stickers after this talk. All right, so let's get down to business. These are the things I'm going to be talking about today. Traditional authentication, or at least what I consider traditional authentication. I'm going to talk about what a token is, token-based authentication, and then a bit about the future of authentication, since we're talking about modern authentication anyway. So, traditional authentication. What do I mean by traditional authentication? Traditional authentication on the web. Usually, when you have a web page, or you had a web page, you have a server-generated page. All the logic gets handled by the server, by the backend, and it just gets pushed to the front end. There's no real logic being happening on the front end. So, you have a user, goes to your web page, or to your web browser, does a request to the web server, gets back the page. Now, if the user wants to access something protected, something that you have to log into, it needs to provide credentials, username, password. You send them to the server, and if they match, you get back your page. Sounds familiar, right? Yes, it does. But you don't only get your page back, you also get more often a session cookie back. The session cookie will get stored in the browser, and every next time you want to access a protected page, a protected resource, you send that cookie. If the session in that cookie is still valid, you get back your page without the user having to log in again and again and again, because that's annoying. So, what's the difference with a traditional web page and a single page application? A traditional architecture, usually, not always, is a browser and a web server. This can be a whole bunch of web servers, but usually it's one domain, one cluster of things, one backend that handles most of the logic. While a single page architecture can be something like this. You have your single page application, some JavaScript application, running in the front end of the browser and accessed by a certain domain, and you can have a whole bunch of APIs that you want to access to get some data, to do some CRUD operations, whatever you want, a main API, a accounts user API, a payments API, whatever you want, and they all live in a certain domain. And this can pose some problems. You can also have something like this, a mobile app, a desktop app, a web app, and they all have to talk to the same API. Who's working on a product or has worked on a product that has more than one client? A lot of you. Now the funny thing is, only the web uses cookies to remember stuff, to remember a session, for example. A mobile app will never use a cookie just because it's something inherent to the web, to a web browser. Desktop app will never use a cookie. So it would be nice if we could authenticate and handle sessions and state or whatever, all in the same way for any of these clients. But there's a few problems with a cookie-based approach. The first one is cookies don't like CORS. Who likes CORS? Usually there's one person who says, yes, and I think you're lying because nobody likes CORS. If you have a CORS problem, what do? You go to Google, you type in, I have a CORS problem, you go to Stack Overflow, which have a booth here outside, and they have the answer for you. Nobody likes CORS, including cookies. Cookies require state, because most of the time in this cookie you have a session, and this session has to be stored somewhere in a database with a validity date, an expiry date, whatever you want. So you can check this session if it's still valid every time you need to check it. But with modern APIs, we want to make it as stateless as possible. So we don't want to have this state, or we want to get rid of this state if possible. And cookies don't flow. You cannot send a cookie issued by a certain domain to another server just because a cookie is linked to a domain. You cannot do something for this, for example. Your API, which has a cookie, a session, cannot send that cookie to another server. That's not possible in most cases. So that can be a problem. So what's the solution? Maybe it's token-based authentication. We'll see about that later. But before I talk about token-based authentication, what is a token? In my definition, a token is a unique identifier representing something. Doesn't matter what it represents, as long as you can take this token and get a representation from it, a session that's valid, something else, it's a token. You take this token, convert it to something meaningful, and it should be unique. That's something that's also a property of a token. There are different kinds of tokens. An access token. Who's ever used an access token before? A lot of you. Who's ever used an ID token before? A bit less. We'll talk about what they are later in the talk. A refresh token. A lot of you, which you shouldn't, but a lot of people do. And we'll talk about refresh tokens as well later in this talk. And often these are opaque strings in the form of a UUID, meaning that this is a UUID that you save in your database, and you can search up the other properties based on this UUID in your database. But it doesn't have to be. For example, it can be XML when using the SAML protocol. If you're using SAML, your token will be an XML file, a blob of XML, which contains a lot of information. And it can also be a JSON Web Token, which are the tokens that I want to be talking about today. At Auth0, we use them as much as possible, just because we like them. They're convenient, they're powerful. And this is a JSON Web Token. And at first sight, it looks like a bit of random characters, numbers, whatever. But if you look closely, you see there's 2 dots inside of this JSON Web Token. And these separate the 3 different parts of a JSON Web Token. Whoever realized that a JSON Web Token was made out of 3 different parts? A few people. Good so. That's very nice. But if you didn't know, this randomly looking blob of characters is 3 parts, and they all have a different meaning. They all have a different purpose. The first one is this part. It's called the header. And basically what this is a base64 encoded JSON object. And this JSON object for a JSON Web Token tells you the type, I'm a JSON Web Token, and the algorithm that is used to sign this token. Tokens can be verified based on on a signature. We'll see this later. But in the header, you'll see which algorithm you need to verify the signature. The second part is the biggest one in the middle. It's a payload. And again, this is a base64 encoded JSON object, which can look something like this. It basically contains a lot of claims, and a claim is a key value pair that has some more information about the client or party that token has been issued for, a user, a client, whatever. So in this case, we have a token that says me the subject, the user ID usually, my given name, my family name, my username, when it's issued at, and most importantly, when it expires. And this is something very important. A JSON Web Token can contain its own expiry date. So you don't have to save this somewhere in the database. The token itself can contain its expiry date. And the payload can contain a lot of different claims. There's a few different kinds. The first one are reserved claims. And reserved claims are the ones that are specified in the spec. So these are subject, issue date, expiry date. A few other ones, these are just issued in the spec of JSON Web Tokens. They are there, the reserved keywords, you cannot use them for something else. You have to use these ones. I mean, you could also put expiry and use that as well, but there's exp, which is per spec. The second one are public claims. And these are a lot of claims that are used often in APIs, but are not standardized through the spec. But there is a list by IANA. If you Google for IANA JSON Web Tokens, you'll find this list, which contains a lot of claims. Let's see if I can enlarge this. Like the ones on top are the ones for the spec. And then you have stuff like given name, family name. It's just for API interoperability, because you might call a given name a first name, or your family name a last name. And if everybody chooses their own way of calling these claims, it might get difficult and confusing to work with multiple APIs to get the same data. So they created this list just for API interoperability. You can still use first name, but they recommend that you use given name, for example. And then the last sort of claims are private claims. And this is basically any information that's useful for you. As long as it's valid JSON, it's okay to put in the JSON Web Tokens. This is a base64 encoded JSON object. But do bear in mind that since this is a base64 encoded object, everybody can decode it, so don't put anything sensitive in there. Don't put a credit card number or whatever in this token. Also, keep it to the bare minimum, because the more data you put in there, the larger your token gets. And as we'll see later, you'll have to send this token with every protected resource request, and it might slow down your network request. So, private claims, everything you want to have in that token that you think is necessary for you to do whatever you need to do with the token. And the last part is the signature. As I said before, a token can be verified based on a signature. And what you do is you take the algorithm that we specified in the header. In this instance, we use HMAC. You take your base64 of your header, you take the base64 of your payload, run an algorithm with a secret key, and you get back a signature. What's important to know is that the header and the payload are inside of this signature. So if you change something in both the header or the payload, the signature will not match anymore, so you need to create a new signature. So based on this, you can verify that nobody has tampered with the content of your JSON Web Token. JSON Web Tokens can be verified. Another very powerful thing about JSON Web Tokens, not only can it contain your expiry date, it can also be verified so you know that the content is still valid or not. Super secret key, usually it's something random. You should never share this, of course. So if we try this out, we have a base64 header, take the base64 of a payload, then run an algorithm. And if we just take these three parts, put them together, we have a JSON Web Token. If we then go to jwt.io, which is a website we created, but it's free for everybody to use, and basically has a debugger which you can use to debug JSON Web Tokens or create JSON Web Tokens. If you would paste it in here, we'll see that my payload is in here, some Bellen. The space got missing because I made a bug, oops. And you see that the signature isn't valid just because my secret was secret and not your 256-bit secret. So if we put secret here, paste it again, you'll see that the signature is verified just because the secret matches, the signature matches, everything inside of the JSON Web Token has not been tampered with. Okay, so some real world examples, because it's nice to say you have a header, a payload, and a signature, but how does this look in the real world? Now, if you have an access token, which a lot of people in this room already have used before, it might look something like this. You have the issuer who issued this JSON Web Token, the authorization server. In this case, it's Auth0. It can be your own authorization server or the identity as a service provider you use. The subject, it's the user ID. The audience, who is it intended for? So which API can consume this token, can use this token. Then the issue date, expiry date, AZP, and scope. If you want to get more information, like OpenID or profile, but sometimes you want to get some scopes for your API, you can also get them inside of this JSON Web Token. So this is intended for an API. This does not contain any identity-related information just because an access token is always sent with an API request. Then we have an ID token, which is an identity token, and it looks something like this. It contains a lot of information about the identity of the person or the user that it has been issued to. My nickname, my name, the picture where you can find my profile picture. When it's issued, subject, audience, and so forth. The same things, expiry date, just because it's useful. But an access token contains some information for the API. An ID token contains some information about the identity of the user that it has been issued for. If you want to create this in JavaScript, you can do something like this, but basically what you need to remember is you take the base64 of your header, you take the base64 of your payload, run an algorithm on it, and you get a JSON Web Token. There's libraries for doing this, so you don't have to do this manually, but just in case you were wondering how to do that, that's how. And all examples up until now have used a symmetrical algorithm to sign this, meaning that you have a secret, and based on this secret you can sign and verify the JSON Web Token. But there's also asymmetrical algorithms which use a private key and a public key. A private key to sign a token, and a public key to verify its signature. And these are the ones at the bottom. There's a whole range of them. They all work a bit differently, but they all have in common that you have a private key and a public key. And if you have a public key, you want to share this with all the the parties that want to validate these tokens. And there's another standard for this, which is called JSON Web Keys. So we have JSON Web Tokens, JSON Web Keys. Looks like this. Again, some JSON with some information about the public key that you're going to use to validate the signature of a JSON Web Token, or validate something else if you want to, because it's not only meant for JSON Web Tokens, it's meant for public keys or private keys, sorry, on the web, but you can share these to verify a JSON Web Token as well. And you can share these in a whole different way a whole different array of ways. One of the most commonly used is if you use the OpenID protocol. You have this .well-known /OpenID configuration route on your authorization server. It's in the spec, and it looks a bit like this. And it contains a whole list of information, which scopes you support, stuff like this. But it also has a JWKS URI, which is basically just some information with all the public keys that you have issued that you can use to verify a signature, and they have an ID. And usually when you get back a JSON Web Token in the header, you can also include the ID, which is this KID, key ID. So if you have multiple public keys, you use the KID specified in the header of a JSON Web Token to validate based on this list. In this case, it's one key, but it can be more than one. So JWKS.json, if you want to share keys. Some people include them in the header of a JSON Web Token. It works in some instances. It's not always the best choice. It's a public key, so in theory you can share them. You can choose how to. This is a standardized way. So JW token, JSON Web Token, JSON Web Key. There's also JSON Web Signature, which is basically just the last part of a JSON Web Token. If you want to sign something to prove its authenticity on the web, you have a signature. JSON Web Encryption, you can encrypt tokens as well, so nobody can read the contents unless you know the public key to decrypt them. I'm not going to talk about this, it's just good to know that there's JSON Web Tokens, keys, signatures, and encryption, which are all based under the Jose standard. And they help you do all of this crypto stuff on the internet because it's JSON based and JavaScript less JSON. It's all very convenient. So let's make a little comparison. On the right, you have a Belgian passport in 4 languages. I know you all know the pain of having multiple languages in your country. We have it as well in Belgium. And what it says is, I'm a passport issued by the Kingdom of Belgium. I'm from Europe. That's about it. So it tells me what this is. And this is basically the same as the header of a JSON Web Token. It tells you I'm a JSON Web Token, and I have been signed by this algorithm. Then the payload. It can, if you look at the passport and you open your passport, it contains my name, my profile picture, my nationality, and also the expiry date of the passport. And if you look inside the payload of a JSON Web Token, it contains some information about who it has been issued for, to use with an API or to use for a client, a user. Some more information about that as well. And lastly, the signature. Every passport has a few of these methods in place to prove that it's the real password. Some UV lighting, hologram stuff, whatever you want. A JSON Web Token has its signature to prove that it's still valid, that it has not been tampered with, that it's the original JSON Web Token that has been issued by your authorization server. So in essence, a JSON Web Token is more or less like a passport, either for a user or for a client to work with an API. It proves identity. So let's see it in action. I have this very cool app which lets me show dog pictures. So every time I click on this button, I get a random dog picture, which is cool, but I do not only like dogs, I also like cats. So when I click on the cat picture, no cat pictures because cats are not as friendly as dogs. What this means is I need an access token to get the actual cat picture, so I need to log in to get an access token. We'll do this by clicking on login. We're taken to Alt0 just out of convenience, log in with Google. And when all of this matches, I have been successfully authenticated. And the first thing you can see is on the top right corner, I immediately have my picture and my username. Just because I did not only request an access token, I also requested an ID token. And as we've seen before, the ID token contains some information about the identity of the user, like my profile picture, like my username. So I don't have to do a separate request to user info endpoint. I get this inside of my ID token already to use inside of your app. Secondly, we got an access token back. So if I click on this button, we get cat pictures. This is my cat, which I'm very proud of. And if you want to look at this at an API level, we have 3 API endpoints. Is this big enough for the people in the back? Can you read this? Okay. So we have our authentication endpoint. We send the username and password. Do choose a better password than password if you do this for real. But if we would post this, we get back a JSON Web Token. Let's copy this for later. Then we have our docs endpoint. And basically, we get back a random dog picture because it's a public endpoint. You don't need a token for this. The cats endpoint, on the other hand, if I try to get a cat picture, it will tell me no authorization token was found. This is because we have to send this access token that we got when we authenticated with every request. You do this by sending it as a bearer token, which is basically the authorization header in your request. Pass along this JSON Web Token, and we get back a cat picture. Now, one of the strengths of a JSON Web Token is that it contains a lot of information inside of the token. So if we would take a token that has been expired and put it in here, our middleware will see that the expiry date inside of the token is not valid anymore, and will immediately say, no, sorry, you cannot get a cat picture because this token has expired. So no need to do some lookups in a database to check a UID against some attributes in a database. Just by looking inside of the token, you can already see that it's an expired token. The same thing goes for if you have a token which is invalid because somebody tried to forge your token, tried to change some information inside of the payload, so the signature doesn't really match the payload and header. It will say, nope, sorry, it's an invalid signature. You're not allowed to use this token on my API. So by just using JSON Web Tokens, you have a lot of different ways in place to prevent users from misusing your API. This can be the expiry date, can be an invalid signature. If the audience doesn't match, because a JSON Web Token can have an audience, which is your API. If it's issued for another API than yours, you can also say, sorry, it's not a valid JSON Web Token for me. So I think this is one of the strengths of JSON Web Tokens. They contain so much information that you have so many ways of preventing illegal use of your API without doing some extra lookups. If you want to know more, JSONWebToken.io is the website I showed earlier. It's made by us, but it's free to use for everybody. And we do not send the tokens you paste in here to any backend server. This is good to know. We do not track them. I mean, we track usage, but we don't track the tokens themselves. They are anonymous. We do not send them to a backend because it's access tokens. You should never share access tokens. That's why. So you can debug them. And there's also a whole list of libraries and a whole array of languages and frameworks to help you use JSON Web Tokens in a secure way. If you want to know more, jwt.io. So are there some downsides to JSON Web Tokens? With every good thing, there's also some downsides. Unfortunately, also with JSON Web Tokens, the first thing and the most obvious thing is invalidation of a token is a bit harder. Just because a token contains all the information inside of it, it can prove its authenticity even if you want to revoke a token. So let's say that I hire you today to work in my company, and I give you access to your email and to your all the systems in our company. So you get JSON Web Tokens back because you're authenticated, they're saved in your browser memory, whatever. But during lunchtime, you say a remark that I don't really like, so I'm like, nah, it's good, you can go, I don't want you in my company anymore. I should actually be able to revoke this JSON Web Token because you don't work for me, but just because the expiry date, for example, is still valid until the end of the day or until tomorrow, the JSON Web Token is still valid. So if you want to revoke a JSON Web Token, you kind of have to go with a blacklist or a whitelist, which is an extra step. So if you want to invalidate them, it's a bit harder. It's not impossible with a blacklist or whitelist. And if you leak your secrets or private keys, you're going to have a headache. That's why they're called a secret or private key. Always keep them somewhere secure so that nobody can get access to them and issue JSON Web Tokens on your behalf. And again, don't put sensitive data in your JSON Web Tokens. It's just a base64 of a JSON object. Don't put anything sensitive in there. So we've seen what a token is. Now let's look a bit at token-based authentication. Again, we have a user, the browser, and the web server. The user does a request. We load our single-page application, in this case, let's say, and we do request to an API. But we want to request something that's protected. Same story, user credentials, username, password, whatever you use to authenticate. send it to the browser, through the browser to the server, and if they match, you get back an access key, an access token, and the page you wanted or the info you wanted. You save this token somewhere in memory, and every time you want to access a protected resource after that, you use this token to get access to this resource, and if it's still a valid token, you get your information you want. It's basically the same as using a cookie, like we saw before, but instead of a cookie, you use a token, and you get your data back. If you want to do this in JavaScript, real quick, the most important part is that you use the authorizations header, and you send your token as a bearer token. And if you do this, your middleware will know how to handle these. And usually people use something like OAuth for this. Who's ever worked or heard of OAuth before? A lot of hands. Cool. OAuth 2.0 is a protocol that allows a user to grant limited access to their resources. So OAuth allows you to grant a limited access to resources. It is not meant for authentication, only for authorization. So you can give somebody access to something or a part of your resources, but it does not handle identity very well. That's why they came up with OpenID Connect. And OpenID Connect is basically you take OAuth 2.0 and you add an identity layer on top, the ID token in this case, and then you get something like this. OIDC, OpenID Connect, was created as an identity layer for OAuth 2.0, and so on. So if you want to do identity, if you want to do authentication, and using OAuth, chances are you actually need OpenID Connect. And maybe you're already using OpenID Connect and you don't realize it because it's so similar. It's OAuth 2.0 with an extra layer. But it's good to know there's a difference between the two of them. So if you look at a bit of a more practical example, you have your single page application living in a certain domain. You want to authenticate, so you go to your authorization server. Accounts.google.com is one of those. If you want to log in on Gmail or on YouTube, you're always taken to this one Google login page. So that's their authorization server. Auth0 is another example. And if you send your credentials and they match, you get your token back. You save them somewhere in memory. But you can not only get an access token back, you can also get an ID token back. And if you really want to, a refresh token as well. You save them somewhere in memory, and then use this access token to get access to your API, like we've seen before. I say you save them in memory, just because you should never save tokens somewhere persistently. This has to do with cross-site scripting and stuff like this. It's very easy to inject some JavaScript if your site is vulnerable and get everything from local storage, for example, to get all the cookies, to get everything from IndexedDB. So you should never, ever save the tokens somewhere persistently, but save them in memory. You get your data back when your token matches. But since we save them in memory, does this mean that the user has to log in every time you visit your website? Because we don't save these tokens somewhere persistently, so the next time the user visits or when you refresh, these tokens are gone, right? Doesn't really mean that they need to log in. If you take the example we just had, login flow remains the same. You get your tokens back, but instead of your tokens or together with your tokens, you also get a cookie back. So we're back to the beginning. This is a session cookie issued by your authorization server. And the next time the user visits, we will do a silent request in the background. Basically, we'll send this cookie through an iframe, which has the same domain as your authorization server, so you don't have to do with CORS and all of that stuff. You send this cookie on Bootstrap of your single page application to your authorization server, and if the session in that is still valid, you get your tokens back, post them from the iframe to your single page application, and save them in memory. This means you can issue new tokens with every time the user visits your website, and you don't have to save your tokens somewhere persistently. Only this cookie, which is an HTTP-only cookie, so you cannot read the contents with them with JavaScript, and it's only valid for the domain of your authorization server. And then you can use your cookies, your tokens the way you're supposed to. Now this is with the OAuth implicit flow. OAuth has a bunch of different flows. The implicit flow is the most easiest, and that's why we use them with single page applications. But the IETF, the Internet Engineering Task Force, has published a new best practices document back in, I think, December, telling you to avoid using the implicit flow because there's some things that can go wrong. Most of the modern apps use the implicit flow, and they have implemented ways to mitigate the risks, and that's fine. But if you're starting out with a new project, try to avoid using the implicit flow and use the authorization code with proof key for code exchange flow, which is a long thing to say. If you want to say it shorter, it's called PKCE, and looks a bit like this. So together with your user credentials, username, password, you also send a code challenge. And basically, on the moment that you initiate your authentication request, you create a private key, let's say, and derive a code challenge from this key. You send this together with your username, password to your authorization server. You get back a code, which is a challenge. And then using this private key, you sign this challenge and send it together with the code back to your authorization server. And by matching this signed code and the initial code challenge you sent initially, it can verify that it's the same client that has started the request because they're both derived from the same private key. It's a bit technical, but that's more or less what's happening every time you do an authentication request. And when that's all okay, you get your tokens back and you do whatever you want to do, like before. So in order about access tokens as JSON Web Tokens, OAuth does not specify, or OpenID for that matter, does not specify that an access token needs to be JSON Web Token. So an access token can be anything you want. It's often just a opaque UUID, but it can be a JSON Web Token. And there's an IETF draft to standardize this. It's initiated by a colleague of mine, Vittorio Bertocci, but it's now an official IETF spec, or it's a draft, and we hope that we'll get a spec just to standardize the way you create access tokens as JSON Web Tokens, the way you put your data in this. And there's a whole draft like this, but the main thing you need to know is instead of type JSON Web Token, you have type access token plus JSON Web Token, and then they specify the ways you can put your data inside of this token. Because up until now, everybody who uses an access token as a JSON Web Token just does whatever they want. That's why they try to standardize this. ID tokens, on the other hand, always have to be JSON Web Tokens per the spec of OIDC. So a note about refresh tokens, because I've talked a bit about them, but I didn't really tell you what they were. I'm not going to tell you, because you should try to avoid them. If you want to use refresh tokens in the front end with single page applications, that means you should try to avoid them unless there's a system of refresh token rotation in place, which means that you rotate your free refresh tokens on a frequent basis, or standard constraint is in place. And standard constraint sounds really cool, but there's no really practical way to do this yet. It's all theoretical, and one day in the future we might be able to do this, but it's not possible at the moment. And most authorization servers do not support refresh token rotation yet. So unless you have one of these two systems in place, of which one is not possible yet, try to avoid refresh tokens and go for the silent authentication request in the background instead, so you get your tokens every time again and again and again, instead of using the refresh token and saving them somewhere persistently, which is very vulnerable. So, does this approach solve for CORS? Who thinks it does? Nobody thinks it does. I think it does, because a cookie is linked to a domain, to an origin. A JSON Web Token is not. It's just a token, a blob of text. And as long as you know how to verify them, as long as you have access to the public key to verify that the content of the JSON Web Token is still valid, you can use them on any domain, on any server you want. So you're not really bothered with CORS anymore. Who thinks that this approach solves flow, so you can pass along one token from one server to the other, one domain to the other? One brave guy, two brave guys, three. A bit more hands. I think it does, because as long as you know how to verify a JSON Web Token, you can theoretically use them. Usually a JSON Web Token has the audience in them, so the APIs that can use them, you don't have to do this, but these can also be multiple APIs. So if both of the APIs are in the audience of the JSON Web Token, you can pass them from one to the other without a problem. Who thinks that this approach solves keeping state? Nobody. And in theory it does, because the JSON Web Token contains all of the information you need to verify its contents and to verify itself. But if you want to use a silent approach, you need to issue a session cookie anyway. If you want to keep a blacklist of tokens which you invalidated, you need to keep some state. So in practice, you usually end up with a bit of state anyway. But JSON Web Tokens were invented to do stateless authentication. It just happens that there's clever people trying to abuse them, so we need to find ways around that. Lastly, I'd like to talk a bit about the future of authentication, because we've been talking about modern authentication with tokens in single-page applications, with complicated flows like the PKCE flow, and it's all fine. But the most critical part and the most vulnerable part of any authentication process is still the user with his username and password. Because who uses a password manager in this room? Not even half of the people. I'm not shaming the others. It's just most people reuse passwords. They have something they can remember themselves. Passwords are often very easy to guess. So if there would be a way to get rid of passwords on the web, that would be awesome. And there might be. It's something called the Web Authentication API, which is an API that became an official W3C spec in March, I believe, so not so long ago. It's often called WebAuthn. If you want to Google more information, it's easier to use WebAuthn than Web Authentication API. You'll find more results, I've figured out. And it kind of means no more passwords. And you might be saying, like, we've had password lists for a long time. Every time I want to log into Slack, I just click to get this magical email with this magical link, and I can log in without using a password. That's true, but they all rely on the certain password that you use at the beginning of your authentication or your registration process. So it's not real passwordless. So if we would be able to log in with, let's say, a private key and a public key instead of a password, that would make it so much secure, if you keep your private key private, of course. And there's a way to do this with an authenticator device. And it's something which looks like this. It's a little USB key. It's called a YubiKey, this one. You have different brands as well. Who has one of these? One person, 2 persons. Very good. It means that if I plug this in, I can theoretically log in, which is this key, this YubiKey, this authenticator device, because it contains a private key, and we can sign stuff with it. So if I plug this in, we can continue. So what you do when you want to authenticate is you request access to something protected. Your authorization server or whatever will send back a challenge. This is a randomly generated challenge, some random data, whatever. Your browser knows how to handle this and sends this to your authenticator device. So the browser communicates with the authenticator device. We ourselves, as developers, do not do this. And the authenticator device is going to take this challenge, sign this with a private key, and then send back the signed challenge and the public key information you need to verify this challenge later on to your authorization server, and we save it there. And every next time you want to authenticate, you're going to send a challenge back to your authenticator device, sign this, and send it back to your authorization server. And based on this first time that this first public key you saved, you can validate that it's been signed by the same authenticator device, my authenticator device, so it must be Sam who is authenticating to your website. And if we look at this in practice, I click on this button and it asks me to touch my USB drive for some reason, and I'm on localhost, so I have to allow it. But when we do so, I got a challenge back, and my authenticator device, my browser API that exposes this, gave me a public key or a raw ID of a public key. So basically, I can use this raw ID to save it somewhere and authenticate in the future. But I've asked this before, who has an authenticator device? And 2 people said yes in a room, so that's not a lot. But I have to ask again, who has a phone or laptop that's less old than, let's say, 5 years or 10 years? And I think all of us have a phone or a laptop that's recently, or more or less recently. And most of these modern devices have a special dedicated chip on them. Apple has the A2 chip. Intel has their own version of a chip that does nothing but credential management, that has a private key that can sign stuff in a secure way. So most of the modern devices have a built-in authenticator device. Now, if we would take this example again, I have a modern MacBook Pro which has Touch ID. So if I click on this, I would be able to log in with just my fingerprint. If I allow it again, I get a raw ID back. So without using this USB drive that I used in the first example, I just used my built-in A2 chip or whatever it's called, and I unlocked it with my fingerprint. If you don't have a fingerprint reader, you can always unlock it with your password of your laptop or your device, and authenticate. So it's good to know that most modern devices have this built in. If they work with your browser, that's not a question. This API is supported by most modern browsers, even Safari, tech preview behind the flag, but it works. Edge has support for it, and now that they're moving to Chromium, they definitely have support for it. Firefox also has support for it, but Chrome is the only one that supports Touch ID for the moment. So if you have an Android phone with a touch sensor, or you have a MacBook Pro with a Touch ID and use Chrome, you can use this already. If you have an iPhone, Safari on iPhone does not support it yet, so you cannot really do anything. But it's coming. As I've mentioned, this is the future of authentication, and we can eliminate passwords by using a public and private key. So how does this work code-wise? You basically have two methods that are exposed to the browser. The first one is navigator.credentials.create, and you give a config, which is a JavaScript object, which contains some public key information, like the challenge that the authenticator device is going to sign. This is a random unsigned integer array, and we take that one as a challenge. You take some information about the relaying party, who is asking for this information, my website, for example. You take some information about the user that is you're going to try to authenticate, my user ID, my name, my display name, whatever you want. And then you have some information about your authenticator selection. So you can filter the kind of authenticator devices you want. If you only want the built-in ones, or you only want external ones, like this USB drive. If you want to have an authenticator device that has user verification, so Touch ID, or have to touch this little USB drive before it actually does what it needs to do. Some authenticator devices allow you to just plug it in and it works, which is a bit less secure. So you can filter those out if you want to. And when you've done this the first time, so you've done credentials.create, you can then use the raw ID you get back and use credentials.get for every next time you want to authenticate, and then some public key information, a challenge to sign again, and then this is the raw ID of the credentials you got back the first time when you did create. You send it along so it knows for which public key to authenticate. And then you can do some authenticator selection as well, like it needs to have user verification. Usually you need to use, not usually, you always need to use this same authenticator device that you use to create your credentials to use to authenticate in the future. But if you want to know more about this, we have created a website, webauthn.me, also created by us, or by me, by Auth0. It looks a bit like this, and it kind of takes you through the whole process step by step. So your browser does a request to your relaying party, your authorization server, gets a challenge back, sends this to your authorization, to your authenticator device. If I choose from my built-in one, and I touch it, it will sign the challenge, send back all the information to my authenticator authorization server. So we got back the raw ID, and if we use this raw ID, we can back our public key information we need in the future. So next time we want to authenticate, we take this raw ID again, send it to our authorization server, get a challenge back, send it to your token. As you see, now I don't get the choice to use my USB drive or my Touch ID, just because I created that credential with Touch ID. And it doesn't seem to work, because why not? But basically, if it would work, it would sign this challenge again with the same credentials, and we would be authenticated. This website has a bunch of information as well if you want to, like so, and a debugger, because the config of these two methods can be quite complex. You can just play around with the config and see what it does. So you can, with this config, do a request and see what happens and what you get back. This is all the information you get back. So if you want to know more about web authentication of WebAuthn, webauthn.me. So let's summarize. Using session cookies is hard with single-page applications. Status authentication is possible with an asterisk, just because blacklists or session cookies, which you use to do silent requests and stuff like this. JSON Web Tokens consist out of three parts: a header, a payload, and a signature. And in the future, we can use WebAuthn to eliminate passwords, because nobody likes passwords, and me especially, I do not like passwords. If you want to know more, JSONWebToken.io, webauthn.me. We have a blog post about why the implicit flow is not okay to use, or what are some of the security flaws with them, and why they advise, the IETF advised to go to the PKCE flow. And our blog is full of other useful information as well. So if you want to know more, check out these links. If you want to see these slides again, jwt.sambego.tech. I will tweet them again later as well, but I'll give you the chance to take a picture. I have to update them, so the ones which are currently on there are not exactly the same, but more or less the same. And that being said, thank you. Are there any questions? Yes, sir. To your right.
In terms of JWT tokens, from what I've seen in the usage, if it gets created on one device, you could easily copy it and use it on another device.
You could as a user, yes, because you can go into your DevTools and debug your network requests, or if they are saved in local storage, yes. Definitely, because it's a token that's portable. It's not meant for that, but that's possible. But that's you yourself doing this. Somebody else.
How do you prevent that from happening? So if
you cannot prevent that if they're used by the same client and the same API, because they are usually issued to a client and an API. So app.whatever you have can use this token to access the API.whatever you have. But which device uses them, it's not specified in the token. They're not meant to be ported over to another device, but you as a developer know how to. But that doesn't mean, a hacker should be able to get access to your computer and do this, but that's a very edge case. So in theory, yes, it's possible what you're doing, but it's not meant for that.
Is there a way to prevent that, to uniquely identify a device?
Not yet. There would be sender constraints, which you can verify that the one sending this token is the one that it has been issued for, but that's not possible at the moment. Any other question? Over there. I'm sorry, how do I solve the problem with JWT tokens? I didn't get the last part.
Okay. What if the JWT tokens has a lot of data in it and it gets really big? Because
you should try to avoid this. You should only put the bare minimum in there.
What if the bare minimum is actually really large?
Then you're either not doing something correct or, it should actually only contain the bare minimum, either the bare minimum identity information. If you want to have more information than the bare minimum, you'll have to do a separate request to get this information, or if you do it as an access token, it's usually just the audience, the issuing party, the expiry date, and the scopes you want. So unless you have a scopes of hundreds and hundreds and hundreds, this usually is not a very big payload, but there's not a way to reduce the number that you think is necessary. That's completely up to the people implementing it. So there's not really a standardized way for that. Does that make sense? Yeah. The only answer that I have for this is try to keep it as small as possible, because you're sending the token with every request, and it does take up some bandwidth. But I don't know your use case. You might have a valid use case to put a lot of data in it, but then maybe JSON Web Tokens are not the best way to go. Not sure.
What's the difference between OAuth 2.0 and the SAML?
SAML is more comparable in a way to OpenID Connect, because it also does identity. It's a different standard. It issues tokens, which are XML instead of JSON, but they're comparable to JSON Web Tokens because they also contain a lot of information inside of them. It's just a different standard. It's a bit older. It's still used, but modern clients prefer JSON, especially JavaScript. So OpenID Connect with JSON Web Tokens is a bit a modern approach to SAML, or what SAML did in the past. But in essence, they more or less, not completely, but more or less do the same. Behind you?
Hi, sorry, so you made a different distinction between the access token and the ID token.
Mm-hmm.
What we do now is what I've seen is that when we use JWT tokens, we actually put a lot of ID information inside as well. And also so I guess I have two questions. The first question is, why should we make this distinction between access token and ID tokens? And the second question is there a way to prevent people from just copying out the token and putting in JWT.io? I mean, you read all the information immediately.
To quickly answer your second question, you can encrypt the tokens, which means that you need to have the public key to decrypt this token. So that prevents people from putting them in JWT.io, for example. It's something that's been done not often, but some people do it. So you can just use JW encryption to encrypt the token. To answer your first question, the distinction is made because an ID token contains information about the identity, which is something that the user wants to see, like it wants to see its avatar on the website, or it wants to see its username. Your API does not have any purpose of using that image or that username. All it needs is usually a user ID, and that's a subject of your access token. So they're meant for different purposes. The access token is really just for an API to consume and to validate if the person requesting access is actually allowed to get access. So it contains scopes, for example, or the user ID, but it doesn't need an image or a username. The ID token is just to show some information on your front end, on your client, like a username and image. So that's why the distinction is made, and you should try to keep it separate. Your API is not going to cry if you send it a username or an image, but it does not need this, so why do this if you can eliminate it? Does that make sense? Okay. We good?
I've got one last question.
One last question, okay.
Yeah, so I have a UB key. So like there's this it's an authentical device, right? So I have this laptop as well, which runs Fedora, and I could use GNOME to set it to be able to log in using the authenticator. But there was once which the authenticator device itself has some issues, and I couldn't log in at all. And then thereafter, I have to put my entire Linux laptop into and then I have to go and turn off that login mode and
yes. When you use something like an authenticator device, you should always have a second way of logging in or recovering from a lost device, for example. If you lose it or if it stops working, you're kind of shut out of your account. So you need to have a backup of accessing that account. Like if you have GitHub set up with two-factor authentication, you get some recovery codes. You have a bunch of different ways to recover a locked account. When using this, you should always try to make sure there's always a backup as well.
Yeah, so that points me to the point which you talked about the future of authentication, where there will be possibly no passwords. So if we are having issues with like YubiKey and stuff, then if we have an alternative method as a form of backup, so there would still be passwords, right?
Maybe that's your backup way, and then you're back to passwords. You can figure out other ways. There's a bunch of different ways. Passwords is one of them. It's the future, so we should figure out a better way. If you have two different YubiKeys, you already have a backup, but that's a bit redundant. But you're right. It could be a password that's your recovery mode, and then you're back to passwords, and then we're back to this stuff everybody hates, or I hate at least. You're right.
Okay. I'm just provoking some thoughts. I hope it doesn't offend you.
No, not at all. But I don't have an answer. Otherwise, then you're right. That's my answer.
Thank you.
You're welcome.